1/3 of your EdTPA is going to be dealing with assessments. And so it's really important that you have a good assessment instrument. In other words, a good way to assess what's going on with your students. So in this particular video, we're going to talk about the key things that will help you create a very good video. Now, the focus on this is on science. However, it's still relevant to health teachers and so forth as well. So what we're looking at right here is the assessment page I've made within the EdTPA page of the student teaching class. So first of all, in task 3, EdTPA task 3, which is basically all about assessments and so forth, that you're going to need to have a multi-day assessment. All right. What I mean by that is that if you just have like a quiz or a short assessment, you're not going to have sufficient quantity of material to comment on and to be able to meet the requirements of the rubrics effectively. So you'll notice that, like, if I look at rubric 12, this is like how the EdTPA is graded. It's going to look here and saying, okay, that you're going to have to provide feedback to guide the learning. So the question is, what kind of feedback does the candidate have to provide to the focus students? So remember that there's 3 focus students that you select representing different subpopulations in your class. One of them has to be English learners. And again, if you don't have people who are designated English learners, people who are struggling more with English language would be sufficient. You might have, students who are designated as gifted and talented, or, whatever your categories are. You need to have 3 individuals who represent the 3 subgroups. So the question is, in terms of the feedback, what kind of feedback do you want to provide? Well, you're going to, that EdTPA is looking for you providing effective feedback. So it's got to be phrased in a way that students can understand. It's got to be relevant to any future work. And so if you look at this grid right here, we can see here that on the x-axis, this is the ease for pupils to respond. This over here is the quality of the feedback. And so if something is very easy, in other words, it's easy to respond to, but little feedback, this is something like, just write the date in the title. Okay, that's not terribly meaningful. Whereas if you have something more like this, like draw particles the same size for pure substances or something, it's giving a very specific type of feedback. These are the kind of feedback you want to provide your students. So in these 2 categories up here, you don't want just really simple stuff like, dot your I and cross your T type thing. So, so feedback is going to be really important. You want to have written feedback. You want to make sure it's in a different color ink than the students' work, so it's very clearly seen as to what you have provided for your students. So if you look back over here, by having a multi-day assessment, one which has that's recorded over a variety of different days that's relevant to the unit, you'll be able to have sufficient material to comment on. All right, so you want various aspects of student work to gather information so that you can deliver better instruction next time. If you look at rubric 15, rubric 15 is how you use assessment to inform your own instruction. In other words, this is your own formative assessment, if you will. In other words, how am I going to instruct better as a result of what I've learned in this assessment? So this is informing my instruction. So you want to see, how does a candidate use the analysis, what the students were able to do to look at their instruction in the future. So again, if you just have a quiz and it's just multiple choice and just numbers and so forth, there's very little data. But if you have samples that include writing samples, they're graphing, interpreting data, and things like this, then you're going to get a better picture of what the student capabilities are. And that's going to be able to provide you with information so you can comment. In other words, how will I improve my instruction next time? That's what this is really asking here. So if we go back over to the sheet here, you're going to want to have multi-day assessments. I'm going to give you some examples of what those look like. So you'll also want to make sure that you specify what your learning objectives are. So I've provided a link here to learning objectives. So learning objectives here really, you want to remember the acronym SMART. They need to be specific. Okay, so in other words, specifically, what are the students able to do? They need to be measurable. They need to be something that you can actually have some kind of a basically a quantifiable scale. They need to be attainable. In other words, something that it was within reach of the students, so it's reasonable. They need to be relevant. In other words, you're not asking things that are unrelated to the subject you're teaching, and they need to be time based. There always has to be some kind of a time interval, generally, whatever the time period of the class or whatever time you've allotted for the assessment. So when you're phrasing them, it may be helpful to use the SWOBOT. In other words, students will be able to. That's what this SWOBOT stands for. So you can start your learning objective with students will be able to do X. And so it's going to be measurable. You want to have action verbs, things which will state what they should be able to do at the end. You'll also want to make sure that they're precise. In other words, so it's really easy to understand what it is you're looking for. And three-dimensional. So in other words, your disciplinary core ideas, your science and engineering practices, and the cross-cutting concepts, all of these, you just click on the links. It'll take you to what's referred to as, the disciplinary core ideas and so forth. And of course, I provide some pages and so forth there for you to look at. So your assessment should also illustrate some aspect of inquiry. Remember that your videos need to show that your students are involved in some kind of an inquiry, some kind of answering questions about, or developing an explanation for why a phenomenon is the way that it is. So if we look at rubric number 11, which is in the assessment portion right here, you'll see that, it says, how does the candidate analyze evidence related to conceptual understanding during inquiry? Okay, so if you don't have an inquiry lesson, then you're not going to be able to do this. And the inquiry just means basically that you are having your students try to answer questions about, why a phenomenon is the way that it is. In other words, that why a phenomenon produces the type of results that are observed. So it has to be an inquiry based. So you're also going to want to make sure your assessment has some kind of phenomenon. So if it doesn't have a phenomenon, then there's nothing to do an inquiry about. And when we're talking about a phenomenon in terms of science, is that it's observable events. Okay, so that's just about anything that occur in the universe, and they can be, natural or man-made. That we use our knowledge of science to explain or predict. So we're using the scientific knowledge. We're explaining, and I'm going to put there and predict, because if you put the and, you're going to score higher. In other words, you want your students to be able to make an explanation of a phenomenon, but you also want them to be able to make a prediction from their explanation. So if their model is good, their model is explaining how the various different components of the system work, then they should be able to make a prediction. In other words, it should describe results that you see, and should also make predictions about future things that we could actually test. So in engineering, when we're talking about phenomenon, they are solutions to problems that arise from phenomena. So let's say that engineers always define a problem, and then they design a solution, and then optimize that solution. So here, engineering is going to be, the phenomena is designing solutions to phenomena. In other words, like, let's say you have cracks in a roadbed that are happening during the wintertime. How would you alleviate that? Well, you're trying to develop a solution to a phenomenon, one that you've actually observed. So that you're going to want to make sure it's phenomenon based. So you want to make sure that students are making predictions. So this is what this is right here, that your assessment has to have someplace in there where it's going to show that you're doing inquiry, where they're answering questions about a phenomenon. So you make sure you describe what that phenomenon is. You need to make sure that they're making predictions based upon their model or their explanation. And again, that goes back to rubric 11. A couple of things you want to have in that is you want to have some data interpretations. You're going to need to have some kind of a data that your teachers or your students, I should say, are interpreting, because one of the things they're going to be asked to do is to analyze that data, and that's part of the first video. First video clip has to show the students organizing and or analyzing data. So when we're talking about analysis, these are the kind of skills that you're supposed to be able to accomplish by the time you're done with middle school. Over here are the ones for high school. So if you look at these things, you can even lift some of the words directly from this. Like, let's say you have some data and you want them to apply statistics, okay, or probability. So what you're seeing here is that if you use the terms that are in the NGSS descriptions of what objectives are supposed to accomplish, then you know you'll be on target. So like middle school students need to be able to distinguish between causal and correlational relationships. So again, causal means that cause and effect, that A contributes to the results we see in B. Correlational just means that A changes as B changes, but they both might be the result of some unknown causal agent C. And so we need to make sure that students can distinguish causation from correlation. So those are all things that would be in the data interpretation. So again, if you click on that link and read the text of what NGSS has provided for you and use the wordage in there, your assessment is going to be much better. Your assessment should also have some place where they're developing a model. Again, a model is really the explanation. And so when we look at a model, we're not talking necessarily about a two-dimensional or three-dimensional model. We're talking about models the way that NGSS defines it. It could be a variety of different types of things. Like it could be an equation, it could be a paragraph explanation for how the various components of a system interact. It could be a diagram. It could be, a physical model and so forth. And so these, again, are things that high school students should be able to do by the time that they graduate. So, for example, they need to be able to evaluate the merits and limitations of models. They need to be able to test a model and then determine its reliability. And so if you read through and again, you use the language and so forth that's already provided for you, you'll make sure that your assessment is in line with NGSS. Now, if you have some free response questions are questions that are somewhat open-ended. In other words, they're questions that are going to involve the person to have to write an answer. Now, if they're writing an answer, this gives you the ability to comment on the student's language use. Now, that's actually part of rubric number 14. So you'll notice that you have to analyze students' language use. So if you have like a true, false, multiple choice assessment, and that's all you have, there's no evidence of students' language functions or the language demands. In other words, how do they use things like the term analysis or to synthesize or to hypothesize? In other words, those three functions of the language. But if they haven't even used those terms in the sentence, then how would you know that they've, how they do, how capable they are of using these language functions? And so as you go through this, that if you make sure you have something which uses some of the content vocabulary and symbols, something that may use syntax, like, for example, like in writing a chemical reaction, knowing how to use subscripts and superscripts and so forth, and which way the direction of the arrows go and so forth. This would be part of the syntax of like a chemical equation, and something that if in a free response question they could reply to. So that in your assessment, you want to have some free response questions so that you can provide some feedback on student language. So again, if you don't have any free response questions, there's no written language, there's nothing for them to comment, you're going to score very low on rubric 14. You're also going to want to provide opportunities for resubmission. In other words, like many districts have gone to a type of grading where it's called mastery grading, where if you don't succeed the first time, you have opportunities to improve but the teacher has given you guides as to how you can improve. Well, if you use mastery grading, then you're set up for rubric 13, because you'll notice that rubric 13 says, how does the candidate support focused students to understand and use the feedback to guide their future learning? So let's say that your assessment um, gives them the opportunity to resubmit a portion of the assessment that they didn't do as well on. Then any feedback that you provide can clearly be used to help support the students to be able to understand and be able to further their learning so they score better the next time. So mastery grading lends itself naturally to rubric 13. So, how will the teacher support focused students to use it? In other words, like if you're going to give feedback, make sure that you review the feedback and you talk about that either in written or free form. So, and then finally, you want to have questions and activities that make use of like vocabulary, symbols, and so forth that we've talked about. That'll help you do number 14, which is all about analyzing students' language use and science learning. So we can see that it's actually very demanding in terms of your assessment. And if you look at health, okay, the health is similar. It's not quite as involved. Make sure you read through the details here if you're doing the health one. So what I want to do is I want to just give you a couple examples of multi-day assessments that were developed by former student teachers and so forth. So right at the bottom, I've basically provided links to ones by Paulo and Dylan. I'm going to just open up Paulo's. It's a physics assessment here. So let me just go ahead and open that up. And so this is going to be a Google Doc here. And so you can look at this and you'll notice, first of all, this is a long assessment. Okay, so if I scroll through, we can see here that it's a number of pages, not just a single page assessment. So he scored highly on EdTPA, and particularly the assessments, like a 13-page thing. Well, if the students in class and maybe at home complete a couple pages every day, they're going to be able to do this assessment. So notice the kinds of things that he has here. He has them to say to draw, set up of your lab. So they're going to have to diagram here. It's going to show how can they interpret the instructions. Can they interpret the instructions so they can set up a lab? So that's a very good way to evaluate a type of understanding. Can they create a visible model of what has been described in writing? You'll notice this next one. Okay, so here they're asked to do something. They use a spring scale, and they're supposed to convert mass here, or not convert, but determine if I have a certain mass, what the weight's going to be given, the acceleration due to gravity, at the Earth's surface, 9.8 meters per second squared. So here you're asking them to do application type questions. If they know the mass of the cart, can they figure out what its weight's going to be in newtons? So now they're doing calculations, and you can see that these next ones here are also going to be calculations involving things like averages, where they actually measure, and then they measure the spring force. So now you're testing their ability to understand certain language functions. In other words, like what does it mean to calculate an average and so forth, as well as their mathematical skills, etc. As you scroll through this, we see that there's ways that they can now look at their ability to understand the syntax of equations. So they're going to complete the table and say, okay, if I understand this equation, I should be able to complete this table. So now we can comment if they're able to do it or unable to do portions of it. We can comment on their ability to interpret, an equation. This next one right here, now they're starting to graph the data. This is all based upon things, forces on ramps and so forth. But he's provided some graph paper here, and the idea is that when you look on the student responses here they're looking for work as a function of mass. So they first have had to calculate, what the mass was, and then the force, and force times distance will give you the work. And so can they actually take that raw data and plot it? So a really good One, again, to test the ability, do they understand the academic language of science, which includes things like generating graphs and charts and so forth. And you can see there's some other ones. Then you get down here, and there's ones here where there's interpreting data. And notice here that they're asking more open-ended questions, like what's the relationship between the work done in the mass, or what's the relationship between the potential energy in the mass. This gives the teacher ability to see the writing skills, not just the science skills, but how you can express those science concepts in writing. And so having some interpretive questions, some open response questions are going to be really helpful. Now notice here there's some higher order questions now, like what's the relationship that can be drawn between both graphs. So it's not just analyzing the data, but now starting to interpret the data, what's going on. Notice key terms, like he's using the term to predict, okay, predict what's going to happen. So now your assessment, you can start commenting in your, reflections on how well they're able to make predictions. In other words, what's their possible sources of error? So one of the things that you'll see in EdTPA's requests you to, the students be able to identify outliers and to figure out sources of error. He's made it very explicit. So all of these things equate to what are potentially points that a grader could check off in terms of your assessment. And again, if you just did a simple multiple choice test, you're not going to be able to give that kind of feedback. If, however, you've written all over this in a different color ink, and again, I suggest that this is one case where I encourage you to actually use the handwritten form, because it's really easy for you to see the difference in your ink versus theirs. It makes your comments stand out. So when the reviewer looks at the PDF that you have of the graded work, they'll be able to see that you gave them feedback throughout. So as you scroll through this, you can see here that, again, there's quite a few different things that are in this one. I'm just going to quickly, go down here to where now he's had to do comprehension checks. Okay, if you really understood this, all right, now they're going to do some other things, like they're going to rank these situations, and they're going to look at these and interpret these charts, and they're going to look at evidence, and they're going to look at reasoning. So that's again part of the requirement for this particular assessments, is they need to be able to, in the second video, need to be able to show that they're developing explanations that are based upon evidence, and they have to use this scientific reasoning. So these are all examples here that come forward from that was just happens to be Paulo's. I'm going to look at one more here. So I'm going to look at Dylan's chemistry example. So let's go ahead and just open up Dylan's assessment. Again, these are real assessments. These guys scored very well on this portion, actually on the entire EdTPA, but on this section. So Dylan's doing one here on the gas laws and so forth. And so we can see here right up front that there's a phenomenon here. This is the old collapsing can, with the condensation and the reduction in pressure. So once again, you're seeing that he's soliciting written information, that, and here we're now doing a pretest, your knowledge from the previous unit about the assumptions of the kinetic molecular theory. So that's going to give them the ability to express kind of at a knowledge level or comprehension level what the context is. Now, once again, they're collecting volume, they're collecting pressure. So as they're doing this, he's making it very clear that they have to include their units. So if they don't collect their units, that's something you can comment on. It's going to be very common that students will drop units, and of course then you can't compare anything, and your measurements are meaningless. But it gives you the opportunity to learn from that, to make sure that you emphasize units in the future, and you're going to write that up in terms of how I'm going to improve for the future. So you want to have things like this in there that you'll in a sense you'll notice that the students probably do forget to do things, but that's just gives you ammunition for how you're going to improve in the future. Once again, they're going to be graphing data. They're looking at parameters, like do they understand what constants are, what controls are, what experimental variables. So this is going to give you the ability to comment on the scientific understanding of NGSS when we're talking about students are able to to construct an investigation, which is part of the science and engineering practices, then if you phrase it in such a way that you can assess their ability to do that, you'll be able to comment and then reference NGSS. So make sure you reference NGSS, whenever appropriate and somewhat frequently. So again, there's far more in these assessments than I have a chance to comment on right now, but you can see that both of these are long assessments. But if you split it out, in other words, you give them a handout and they complete the first 3 pages one day and the next 3 the other day and so forth. By the time you collect it all, it's a very comprehensive assessment, but it's very doable for the students as well, time-wise. So here, once again, you're seeing the students are making predictions. They're going to be doing calculations here. And now that one of the things that's really important is that can you make connections? Like here we're talking about something in the lab which really isn't, it's not very meaningful to the students, a cylinder or something like that and changes in pressure. But in terms of now making connections to the real world, can students take their concepts and make explanations about real world phenomena, and particularly if it pertains to them, like how they inhale, how they exhale, how they use, the gas laws and so forth in that process. So anyway, you can tie it into real world phenomenon or to things that are going to be very meaningful to the students that's also going to be a plus. One of the things that's going to be evaluated actually throughout your EdTPA, but particularly in terms of the assessment. So you'll always want to have them developing a model, just as we mentioned in the last, exam from Pablo, that if the students can make a model, that's going to explain how different components of a system interact. And that's again, the most commonly used verb in terms of the next generation science and engineering practices. Students will develop and use a model. And once again, here he's asking to something cut relatively open-ended here, to develop a model and explain the demonstration shown. So again, plenty of writing, plenty of diagramming that they can do in these things here. And so here he gives them a template for what to do. So they can put their up arrows or down arrows representing the buoyancy vector or the gravitational vector and so forth to show how things work, to assess their understanding. So here, provide some kind of a template to which the students can, make their predictions. You'll get better results from your students that way, but you'll also be able to comment, can they make sense of diagrams? So basically here we're doing calculations. So these things are all just calculations, which are very appropriate for chemistry. And they're doing more data collection. And this is going to illustrate how they organize data. So for example, their pressure measurements have got to be in this column, okay? Their temperature ones have to be in this column. And their pressure, for the hot one has to be there, and their temperature for the cold one has to be there. So this is going back to the first video where they have to show them organizing and then eventually analyze the data. But you first have to organize it correctly, make sure it's in the correct tables, the correct form. So here, again, you're testing graphing capability, just like in Paulo's and so forth. And now your understanding of the scientific principles. So they actually understand the Lusak's law, so forth like this. You brought them forward. So as we scroll through here, don't shy away from the math. Make sure that you mention there that one of the things you want your students to do is use computational reasoning if your assessment lends itself to that, because that is one of the science and engineering practices and so forth. And again, making predictions, So here he's got a nice little diagram right here of a deflated NFL football and so forth like this. And he's asking some practical questions. Okay, what happens, if there's going to be a temperature change? What effect will that have on the football? And so here's something where he's tied into real world experiences again, just saying, okay, that what we're learning here whether it's breathing, whether it's football and so forth like this, that it has relevance. And as you scroll through this right here, he's again ultimately coming down now to the revised model. So this is going to be, if you notice that in the first one up here, they're asking to create a model, and then they're revising the model to know why that can collapses. And so here we have a phenomenon. We start with the beginning in terms of the phenomenon itself, and then to going through the various steps with the gas laws and the scientific principles to try to understand, okay, now how does this work, so we can make a more comprehensive and more accurate model of the system. So those are some things to look at. There's quite a bit there, but you'll hopefully get the idea that you really want to spend time constructing a good, solid assessment, which has multiple factors in it, so that you can reflect on those, and you can comment, and you can provide data on them for the third component of EdTPA, which is the assessment.